Okay, thanks everyone very much for coming. Welcome to our session on neuroinformatics and data sharing. My name is Ashley Stewart. I'm in the Neurodesk team. I'm in Stefan Bollman's lab, but he wasn't feeling very well today, so I'm here co-chairing today. So I'd like to introduce the first talk by Golia Shafiei, Reproducible Brain Charts, an open data resource for mapping brain development and its associations with mental health. All right, thank you very much.
Let's do this. All right. So I'm super pleased to present work by all-star postdoc in the lab, Golia Shafiei, Reproducible Brain Charts. So I've never seen these slides before. I'm going to click through so I can see what we're dealing with. All right. So why did we do this study? Major mental health disorders are increasingly conceptualized as disorders of brain development. But if we want to understand mental health, we got to understand both normal brain development and abnormal brain development. And if you want to chart normal brain development, we need big samples. Different kids are different ages. If you want enough resolution to chart brain development at different ages, you're going to need big samples. And if you want to chart abnormal brain development, even harder, you need bigger samples. So one potential solution to get to these big samples is to aggregate data from multiple different data sources. However, even though there's a lot of awesome, big developmental studies out there, they're required under different conditions, different scanners, different measures, hard to put together. So what you see in the literature is that often many labs will take a data set, they'll work on it, a different lab will take another public data set, they'll work on it, but very few people put it together. So what we want to do is do all the painful, unsexy stuff for you guys so everyone can just get the data for free, go straight to doing some good science. So RBC is first, I should acknowledge at the beginning, this is a study I co-lead with Mike Millam, open data all-star. He really led my journey towards open science, and I've drank his Kool-Aid. So RBC pulls together 5 different developmental data sets, total N over 6,000. It includes the Brazil high-risk cohort led by Giovanni Saloom, the developmental Chinese color nest project led by Xinyan Zhou, the Healthy Brain Network led by Mike Millam, NK Rockland also led by Mike, and then a study at Philadelphia, the Philadelphia Neurodevelopmental Cohort led by Raquel Gurr, a study I've worked on since I was a postdoc. I guess I'm old. All right, so it includes structural and functional data, and we pulled together across all these different data sets. Critically, we didn't just get the imaging data, but we also got demographic data and then harmonized the phenotypic data about psychiatry. That was one of the hardest parts. Giovanni Saloom led that. And so if you look at the age distribution, it's really about brain development, but because NK Rockland is a lifespan study, it does include some older people also. If you look at even mix of males and females across the different data sets too. So one thing that's, as I said earlier, that's particularly important is psychiatric harmonization, in terms of measurement of psychiatric symptoms, is very challenging. Different studies measured psychiatry differently, and then there's different, in terms of item response properties across different cohorts, that's challenging. And so what we did is, and by we I mean Giovanni Saloom, Tyler Moore, Mauricio Hoffman, and others, we took the different measures from different studies and then projected them to a latent space with a factor analysis called the bifactor model. Bifactor models are awesome because they reflect the overall conception that in psychiatry, comorbidity is the rule, not the exception. So if you have one illness, you're likely to have many illnesses. So there's this big thing in the literature, just like overall intelligence, something called P psychopathology. And so overall psychopathology, or the P factor, is the general factor in this bifactor model here. This pointer doesn't really work. It's okay. So it's the overall liability to mental illness across different domains. And so by using item response theory, we're able to combine the measures across all these studies and make sure that they're relatively equivalent so we can combine the data easily. This was, in some ways, had nothing to do with imaging, was one of the hardest parts of the study. And so you can see if you look at pre and post harmonization of the psychiatric instruments across the different samples after harmonization, looks much better. Next, in terms of the imaging data, over time, we have become rather obsessed with reproducibility. Reproducibility is challenging, especially as you get to these large data sets, simply because there's so much different data in there. I've been working on the PNC again since like 2008 when I was a postdoc, and it wasn't until recently that I realized the variety of the imaging data we acquired. The way we can see this is a tool we developed for RBC that is now in wide use called QBIDS, led by Sidney Kovitz, Matt Cieslak, and others. It's a way of curating and viewing your metadata in your imaging data, particularly useful for large-scale imaging aggregations. And then after that, we process the data with FreeSurfer, SMRI Prep, and the functional image processing data was used CPAC Mike's tool that he's developed at CMI. Importantly, we want this to all be open and fully tracked, and I really believe that the best way for people to believe you is to show them everything. Sunlight is the best disinfectant, and so we leveraged the capabilities of DataLad and used a completely reproducible workflow for all the image processing throughout, so you can see what we did. If you see we did something wrong, please tell us. So in terms of what you can get, RBC provides fully processed images, but also provides BIDS curated raw data if you want to run a different pipeline. The structural derivatives include cortical thickness, surface area, folding and curvature. The functional imaging data, really rich array of derivatives, time series matrices, scalar measures, you name it. In terms of the different atlases, if you don't want to take the 100 terabytes onto your server, we've got a lot of different parcellations available, so you can use reduced data. In terms of the QC, again, I honestly think that in these large data aggregations, BIDS curation and QC are actually the hardest parts. So we did the QC for the community, so you don't have to redo it. Because if you do the QC differently across different data sets, you're going to get different results. So we want to do a harmonized QC across all these different data sets. The structural QC, painful. We did manual QC of all 6,000 images with multiple raters after an extensive training process. This was led by Natalia Esper, second author of the paper, led by Mike Millam and Alex Franco. We also used automated quality measures such as the Euler number to validate this and provide more automated measures. You can see that the QC varied across the different cohorts. HBN, the Healthy Brain Network, that's a sample that's enriched for clinical psychopathology. Unsurprisingly, they had worse QC. And again, you can see if you plot the average rating here versus in terms of the quality rating from the manual ratings versus the automatic rating from the Euler number, you have this expected relationship. In terms of the functional QC, we used like frame displacement and image, but we also looked at image registration quality because sometimes you'll have problems with the field of view or the mask overlap or the co-registration. We have quantitative measures of that and then evaluated things that were at the borderline. And you can see, as expected, that in general, as kids grow up, they tend to move less. You don't really need a huge imaging study to do this. You can just look at children. But anyway, that is what we found. So in terms of what we found from the study, we looked at developmental changes in cortical thickness. Golia modeled this with GAMs, generalized additive models with penalized splines. And what we first is we looked at it pre and post QC and then pre and post harmonization using tools developed by Taki Shinohara in the back there, an awesome tool called CoveBat GAM. It's like Combat but better. And you can see that in terms of the look at the combined data pre-QC and harmonization, then after QC and harmonization, what looked like a kind of you can see the trends, but they're rather disparate. After you do all this careful stuff, it really converges, and you see these really tight convergent developmental trajectories. There you go on that plot there. So you can see how these initial fit lines across the studies initially are quite divergent. After you do harmonization QC, they really come together as you hope they might. So to end here, RBC is a data resource. Hopefully it allows all of us to run faster and do better science and not get bogged down in boring things we don't like QC and BIDS curation. And importantly, we provide the raw data, we provide the process data, all without a data use agreement. You don't have to go to your signing official. You don't have to renew things. Just go to INDI, the International Neuroimaging Data Initiative, set up by Mike. It's all on AWS. There's no egress fees. You just download it. You do science. And if you have feedback, please let us know. There's a poster, there's a QR code, and a lot of people are already using it. This is an old plot, but I think we're over 2,000 downloads already. I want to end by thanking the first author, Golia Shafiei. She's not here. She's amazing, senior postdoc in the lab. For people who are hiring in 2025, she's going to be on the job market soon. I want to thank Mike, who's the co-leader of RBC with me, and the huge team that makes this possible. Thank you.
For standing up and doing such a great talk. Maybe you can stay at the podium. We have 2 minutes, if you don't mind, for questions. I would invite anyone at the microphone, and we'll take also questions from the app. JB, go ahead.
Just a quick question on the QC aspect with different sites and different data sets. Obviously, the same criteria of QC for movement, things like that, would not apply to the various data sets. How do you deal with that question?
Well, actually, the same criteria was applied because of we had manual raters trained on training data first, so they converged, and the training data was drawn from across the different data sets.
So you didn't have a data set with, let's say, a lot of more movement, or I mean, different type of movement, such that you have to set different threshold or different. You didn't have that.
Yeah, no, I think you're right. Like, it's a good point. Is that it's not a fine-grained QC. Right. It's like a pretty coarse-grained QC that was like scalable across 5 raters and 6,000 images. So it was basically like really bad. Don't use it under any circumstances. Like, okay, maybe, but might be good for like volume, but not a cortical thickness, and then looks good.
Okay.
And so that we thought was scalable. When we piloted it a little bit, it was when we got to finer grain measures, it's just like didn't seem like it was reliable.
Thanks a lot.
There's a question from the app asking you, Ted, whether there's any medication exposure data or physiological data that comes with the package, so to speak, or longitudinal data sets.
Yes, excellent stuff. As you imagine, when the goal is to make it open without a DOA on the internet, there's like a lot of negotiation among sites as to what they're comfortable with. So we kind of went to the highest common denominator among the different data sets for releasing it on Indy. The component studies have a lot of rich detail. And some are more available than others, but especially Mike's data set, Healthy Brain Network and NK Rockland, those are in the same ID system from the parent portals that those data sets are released with. They have medication exposure. There's, especially NK Rockland, there is longitudinal data, and then we hope to add more over time.
Okay, thank you so much. Thank you, Ted, again.